These yellowish-green crystals, they can light up a city or destroy it in an instant. Hidden deep underground for thousands of years, they have become the most dangerous and rewarding discovery in human history. And yet, so how do we find this insidious element of nature? Do we control it, or does it control us? Today we reveal the secrets of the most powerful and controversial element in the periodic table. Yellow-green crystals glittering in deep mines, an element that changed the world's energy balance. After thousands of years asleep in the ground, it has become one of the greatest discoveries in human history. It both gives life and destroys it. This is the dual face of uranium. But how was this element discovered? How were its properties solved? And how did it shape human history from Hiroshima to nuclear power plants? Here is the extraordinary story of the most controversial element of the periodic table. Atomic number 92, symbol U. This heavy metal in the actinide series of the periodic table is found in nature mainly in two isotopes, U-238, 99.284%, and U-235, 0.711%. This small difference was important enough to change human history. Because when bombarded with neutrons, U-235 could split in a process called fission, releasing enormous amounts of energy. The complete fission of 1 gram of U-235 releases 20,000 kilocalories of energy. That's 2.5 million times the energy from 1 gram of coal. So how was such a powerful element discovered? In 1789, German chemist Martin Heinrich Klaproth was studying a black mineral called pitch blende from Bohemia. When he dissolved it in nitric acid and heated it, he obtained a yellowish compound. His analysis showed that this was a new element. Klaproth named this element uranium after the planet Uranus, which had been discovered 8 years earlier. However, pure uranium had not been obtained at that time. Only its oxide had been isolated. In 1841, the French chemist Eugène Melchior Pelaget reacted uranium tetrachloride, UCl4, with potassium to obtain pure uranium metal for the first time in history. This was a critical step in understanding the element's true properties. Pelaget discovered that uranium is a dense, silvery white metal that oxidizes slowly in air. In 1896, French physicist Henri Becquerel noticed that uranium salts darken photographic plates without light. This was the first evidence of natural radioactivity. Becquerel's discovery deeply impressed Marie Curie and her husband Pierre Curie. By processing the mineral pitch blende, the Curies discovered polonium and radium in 1898. Marie Curie named these mysterious rays radioactivity and proved that uranium emits alpha, beta, and gamma rays. These studies laid the foundations of nuclear physics. But the real revolution would come in 1938. In 1938, when German chemists Otto Hahn and Fritz Strassmann bombarded uranium with neutrons, they got an unexpected result. The uranium nucleus was splitting in two. This process was called nuclear fission. Hahn's colleague Lise Meitner calculated that this reaction released an enormous amount of energy according to Einstein's formula E equals mc squared. This discovery triggered the Manhattan Project during World War II. In 1942, Enrico Fermi initiated the first controlled chain reaction at the University of Chicago. In 1945, the little boy bomb made of uranium-235 destroyed Hiroshima. Uranium was no longer just an element, but a force that changed world politics. Today, uranium is used in many fields, from energy production to medicine. 10% of the world's electricity comes from nuclear power plants. It targets cancer cells and radiotherapy. The Perseverance rover sent to Mars carries an RTG, radioisotope thermoelectric generator, powered by heat from the decay of uranium. But uranium is also the raw material for nuclear weapons. As of 2023, there are 12,700 nuclear warheads in the world, most of them powered by uranium or plutonium. So, is this power a blessing or a curse for humanity? Nuclear power reduces carbon emissions, but accidents like Chernobyl and Fukushima pose risks. Uranium mining has caused radiation sickness in communities like the Navajo people. The safe storage of nuclear waste is still an unsolved problem. Uranium is one of the most powerful elements available to humanity. Whether we use it to destroy or to advance life is entirely up to us. Perhaps in the future, fusion energy or clean renewable sources will replace uranium. But right now we are still in the uranium age. And the story of this element reflects both the brightest and darkest sides of humanity. If you enjoyed this documentary, don't forget to subscribe to our channel and leave your comments. In the next episode, we look at plutonium, uranium's deadly cousin. See you soon.